Hey, hello, my name is Arthur Grouse, and in this video I'm going to give you an introduction to Spark. If you look at the Microsoft Fabric architecture, you see Spark is a big part of it, especially if you're working with Lakehouses and you run some code in a notebook, then you use the Spark engine. Whether you use Python or Spark SQL, it's all handled by the Spark engine. Let's take a look what is Spark actually. It's a distributed computing system, meaning code is running on different nodes. Like if you want to query a big data set with billions of rows and you want to do some transformation, some ETL, it's not run on one box, but there are multiple worker nodes as they're called, like 2, 3, 4, but maybe even 100 or thousands of nodes, and they're all gonna process part of the data. So it's fully distributed. It's developed by Berkeley, the R&D department, 2009, so it's not really that new. And in 2013 became part of the Apache Software Foundation, just like Hadoop, the predecessor basically. It's written in Scala, that's like a Java dialect, so you can also use Java and Scala to program in notebooks. But most people don't do this, they use Python or R, because these are more common languages for data science and data engineering. And a lot of APIs also in Python and R. And it's a lot faster than the predecessor Hadoop. It's like 100 times faster. In Hadoop, a lot of temporary results were saved on disk, and now everything is fully in memory. So that makes it lightning fast. What kind of use cases are there for Spark? First, what you're going to do probably the most in Fabric is use it for data engineering, ingest some data in like a bronze layer, transform to a silver layer, and then make it into a gold layer. You can do all your transformations in Spark using PySpark mainly, or R if you like. And it's distributed, so you can scale up, it can handle big data, billions of rows, is not really a problem. Also machine learning is a nice use case for a Spark, especially if you have a lot of training data, then you can spin up lots of nodes and do all kind of machine learning. There are even some machine learning libraries inside of Spark, but you can also use other Python libraries or R libraries if you like. Real-time stream processing, data coming in real-time. There are also some libraries for that. And last but not least, you can also do graph processing and connect lots of nodes together and see how they work together. How does it then work? For example, if you're working with PySpark, you can basically use two APIs. PySpark is the Python version of Spark. The Python libraries are in there. So you can use Spark SQL. That's like a dialect of T-SQL. You can do a select from where with some joins on the tables that are in your Delta Lake, in your Lakehouse. Or you can use the data frame API and you can do ETL kind of things like with pandas. Or like you can do in Power Query with the language M. It's more or less the same like that. So you have some API to work with from Python, and then the Catalyst optimizer will optimize it and turn it into resilient distributed datasets. So whether you use SQL queries or data frame operations, in the end it doesn't matter. The performance is the same because they'll all be translated into an optimized logical plan. Here you can see the whole flow. So SQL queries and data frame, they will get a logical plan. So what will be the steps to do the thing that you want to do? Maybe you want to join two tables. How to do this? Let's go look at it. It's basically the same like in T-SQL, like an execution plan. It's more or less the same. Then this logical plan will be optimized. Maybe you do a few operations that can be done more efficiently in a different order. It will reorder it then. And then it's going to create physical plans. And the physical plans will in the end be generated in RDDs. And this is basically the only thing that Spark understands at the lower level. These are resilient distributed data sets. A set of operations combined with the data that you want to work with. And these RDDs will be executed in the Spark clusters and in the nodes. Let's see how this works. What is a resilient distributed data set? It's one of the core data structures of Apache Spark. Normally you don't use it directly because we have the data frame API. That's way more easier than working directly with this, but which actually you could. You could create your own RDD in Python if you like, It's resilient, meaning it's fault tolerant. So if one node fails, then it can do it again and again until it works. It can do all the recomputations. It's distributed across lots of nodes, if you like, and is a data set, so it also contains the data that you want to work with. And distributed means that this data set is split up in small parts and they will be processed across a lot of nodes. The operations can be transformations or actions. Transformations can be like filters that you do where, or that you want to do some grouping, or that you want to map, transform the data, split some columns, or do some calculations. And then here we can also do some actions on that, like do a top 10, or do a counting, or there are a lot of things that you can do, basically the same like in SQL Server. And then it will put all the RDDs in a specific lineage with all the transformations and actions. So it basically this will be like a to-do list. First take this data, do these operations, and then take this data, do these operations, and it's like a total to-do list for the computer that it knows what to do. And then in the end, these RDD operations, they need to be executed. So that's where we have the directed acyclic graph scheduler. It's a difficult word for me. And basically what it's going to do, it's going to look at these operations that you have in the RDD with all the different data set objects that needs to be combined, for example. Maybe you have two tables that need to be merged. That's all in this RDD. And in this DAG scheduler, it's going to split it up into stages of tasks, separated tasks that need to be done. And then these tasks will be given to the cluster manager, and it will schedule it and give it to the different worker nodes. So we have a driver, and the driver is responsible of creating nodes, for example, adding some extra worker nodes if you need. And these worker nodes, they have an executor running on that with some cores, some CPUs, and it can multi-threaded run different tasks. So if you have like 5 or let's say 8 cores, then maybe it can run 8 tasks in parallel. And with that, if you have like here 8 tasks running and here also 8 tasks, you can run 16 tasks at the same time distributed. And all these tasks will have part of the data set, like 1/16 of the data set, and do its magic on that part of the data set. And then at the end, all these different data sets will be combined in the driver node. It will append them into one big data set and then return it to the client. You see there are a lot of bits and pieces. Maybe it's a little bit complicated at first. The most important thing to understand is that everything is fully distributed, and then that the thing that you do using SQL or with the data frames API will be fully optimized, and it will be split into parts, and it will be fully distributed across a lot of nodes. If you want to know more about these data frame APIs and the Spark SQL, look at the Fabric Code site, and we have a lot of other articles about this. Hope to see you there.